Hey, Algebra 1. Uh, Hey, Algebra 2. Thought I'd make a quick video of the review for you guys tomorrow. Um, Please hit me up and remind if you have any questions. Come in early before class starts. And if you have any more questions, I'll answer quick questions when we start the final period. But just know I'm not going to have much time to review or anything like that like we do for the quizzes. Okay, so let's start this video. So for the review, I'm going to go page by page. So each video is one page. So there will be a total of, what, 5, 6 videos, because one for each page. Okay? All right, so this first page has to do with a lot with exponentials and logarithms, which is all Chapter 8. So if you're looking at your notebook, go to Chapter 8 for this. And this first problem is solving exponential equations. So first thing is you got two options when you're solving these. Remember, look for the keyword says solve. So option 1 is make these bases the same, make the numbers the same, and then they'll cancel out. Or I can use log on both sides. And either one you can use, but making the bases the same is a little bit easier to use and less trickier decimals involved. So anyways, what I want to do first is, since I have a fraction on the right, let's change it to a non-fraction. So what I can do is I can simply, if it's 1 over another number, I can flip it, and then the power of this number becomes -1. It just changes to -1. And now I want to say to myself, can I change 8 and 32 so that they have the same number or base and just raise it to like a power, some power, so that they're still equal numbers? Well, 8 and 32 are both multiples of 2, so I'm going to raise 8 to the power I'm going to change 8 to 2 to the 3. Okay, and just remember I still have this exponent of x out here. And then 32 is also equal to the 2 to the power of 5. And I also still have this -1 out here. And remember, with any exponents on the outside, we multiply those. So it's 3 times x, which n equals 5 times -1. So that's -5 there. And once you get to this point, you can just cancel the base. As long as those two numbers are the same, you can cancel it. And now you just have this simple equation, 3x equals -5. Divide both sides, like you would. And there's your answer right there. X equals -5 over 3. Okay? All right, so number 2. Now this says to evaluate, basically figure out how much is this actually, how much is this? What's the quantity? All right, so we don't know what the quantity is, so we're going to call it x, or we could call it a, either way. So what we're going to use is the property that says I can change this into exponential form. We can go from log base of an answer equals e, and we can take those same numbers and change it to exponential form, and now the base becomes your b here. The e is your exponent, and then the a goes on the other side of the equal sign. So that's basically how you can flip back and forth between logarithms and exponential form. So here, the base is 4, and then the e here is x, and then the a here is 64. And then I'm going to do the same thing I did above. What number could I change these to so that they have the same base? Well, I know that 4 is a root of 64. So, and I would have to multiply 4 3 times to get 64. Now I have the same base, cancel them out. X equals 3. Okay. Now again on the next one, evaluate. Remember, like I told you in number 1, if I have a fraction, I can change that to a negative exponent. But first, set it equal to x. And just like we did up here, change it to exponential form. So we're going to do 5 to the e, which is x, equals a, which is 1 over 25. And now this looks like a lot like the first problem. All right, so we're going to flip this. And remember what happens to the exponent of 25. It becomes negative. Now I know that 5 is a root of 25. So I can change this to 5 squared so that they have the same base. And don't forget that exponent outside. We want to multiply those two. So now we get 5x equals 5 to the negative 2. Cancel those out, and we get x equals negative 2. Okay? Next one. Now these next two, it's asking to expand these logarithms. So we're going to use the properties of logs. Again, this is also in your notebook. If you go to, I'm looking at my notebook right now, right here where it says property of logs, okay, this talks about different things we can do with logs and expanding them. So the first one is here that we have a rational, or a number over another number, a fraction, or simply division. Okay, I can expand this into two different logs. Remember, now keep the same base of 5, and the number on top will go first with the first log. The number on the bottom will go with the second log. Oops, sorry, not 4x, just 4. And between the two logs, it will be minus, or subtraction. Okay, so again, if it's division, you put minus between the two logs. And then the 3x goes here, and then the 4 on the bottom, or whatever number is in the denominator, goes on the right. And make sure you do it in that right order. The number on the top goes first, number on the bottom goes second. Okay, now here, there's 3 terms in here. Here there was 2, one on top of the other. Here there's 3, and they're being multiplied. So it's 6 times x to the 3 times y to the 9. So I can separate these, or expand them into 3 different logs. Again, all with the same base of 4. With multiplication, it doesn't matter what order you go in. It matters with division. But I'm going to go ahead and follow the same order. So 6, then x cubed, then y to the 9th. And with multiplication, it's the opposite division. It's separated by addition. So you basically put plus in the middle, and that's the difference. Now there's a step further you can go here. One of the properties of logs is that if I have an exponent with the answer, or a value, I can move those exponents to the front of the log. And you might see that as one of your multiple choice answers. So now this becomes 3 times log base 4 of x, and plus 9 log base 4 of y. And that would be what you expand it out to. So be careful if it's division, be careful not to choose plus here. And if it was, let's say, one of the options in multiple choice here for this one was minus, you want to make sure you choose the one that's addition. Okay? All right, so now solve. That means we have to find x. All right, so there's x right there, right? So we're going to use the properties of logs to solve this. Now, if I can get one log on one side of the equal sign and one log on the other side of the equal sign, they will cancel out. But right now I have 2 on the left, so I need to combine these. Whereas in the last couple of problems I was expanding it, I was like basically expanding it out. Here I'm going to condense it, do the opposite, put these together. Now if you notice in the middle it's plus, and as we saw with the last problem, if there's plus in the middle, then we can condense it with multiplication. All right, so on the left, this is the same log base 5, and we're going to multiply x times 4, so which is 4x equals log base 5 of 32. And the nice thing is that once I have one log here, they will cancel. And then it makes a nice, easy equation to work with. So cancel out the 4, divide 4 both sides, and x equals 8. Okay, next one. And you can always plug that back in to check it, just like with any equation. And if I plug that in, it should equal the same, right? So if I put 8 here, and then I condense it, 8 times 4 is 32, so that would be equal. Okay, so now I'm going to use that property of where I can move a log or convert a log to an exponential to solve this next one, because I know that I can change this to 4 base raised to the power of 3, because remember this number goes here, and then the a goes on the other side of the equal sign. And then it becomes a simple equation to solve. But first, 4 cubed is 64. Okay, and then just do what you do with solving equations. Add 6 both sides. 64 equals 70. Divide 2. And x equals, what is that, 35? And there you go. Okay. Next question. Write an expression that represents x. In other words, convert this out so that it's all equal to x. Okay. Well, in order to do that, I got to get x isolated. And you can really just think about this. What you're doing is solving for x. Okay. So let's pretend that we're just solving for x. Okay. So here, let's compare this to number 1. Number 1, we changed each number on each side so that they had the same base. But we can do that because they're both multiples of 2, and 2 is a root of both numbers. Now if I go down here, the only number that is a multiple of, that these are multiples of is 1. There's no number that will divide into them except for 2, but then that doesn't get, those aren't roots of either number. Okay, so we can't change these numbers to have the same base, in other words. So what you can do is log both sides. This is option 2. Oops, sorry, the x has to stay as an exponent. So I'm going to log 6x and then log 58. You notice I didn't have to write a base here. All right, you don't have to, unless it actually has a base that already pre-written. And remember the exponents, I can move them to the front, and you'll want to do that. And so now I have x times log 6 equals log 58. And then to isolate x, I just divide the log 6 on this side, and that cancels it. And now I have log 58 over log 6. So x is equal to log 58 divided by log 56. I'm sorry, log 58 divided by log 6. And so that is the expression that we're looking for, that log 58 over 6 would equal x. And on the test, I may ask for the decimal, but here, that's all we need. Okay, we don't have to work that out. You could plug it in the calculator, find the decimal if you'd like, but we're not going to. Okay, number 9. Does the expression below represent exponential growth or decay? And that is it. That's all you have to answer here. Okay, so there's 2 numbers here that give us information. There's one in the front. Okay, we call that the A, and then there's one after that we call the B. What's important is this number to the right, the 2/3, and that we call the B. And simply, if it's less than 1, and remember, it could be a fraction that's bigger than 1, but we have to pay attention because, you know, if it was 3 over 2, that's bigger than 1, okay? If it's less than 1, it's going to be decay. And if it's bigger than 1, it's growth. So simply, if it's smaller, it's decay. If it's bigger, it's growth. Okay? So that's really all you need to know there.